Hi guys, let us consider case 4 of resultant vectors. In our previous videos, we've considered case 1 when two vectors are acting in the same direction, case 2 when the two vectors are acting in opposite direction, case 3 when the two vectors are acting at right angle to each other, and case 4 is what we are considering in this video when the two vectors are acting at an acute angle, say 60 degrees to each other. So if you look at this, vector 1, 3 Newton, vector 2, 4 Newton, both are acting on this object at an angle of 60 degrees to each other. We are to look for the resultant, R, the magnitude of the resultant, as well as the direction of the resultant. The resultant just passes through the center, not really the center, but passes in between the two vectors. So we will know the magnitude and the resultant of the resultant as well as the direction as we continue this solution. So watch and see. The first thing we want to do is to complete this into a parallelogram like this. We complete the other side so that we form a parallelogram of this nature. If this is 3 Newton, then obviously this should be 3 Newton because they are the parallel sides of a parallelogram and they are equal. Now we've completed this shape into a parallelogram, we can solve for the magnitude of the resultant R. So we are just going to solve for the magnitude. But before we solve for the magnitude, let us look at this triangle here, the bottom triangle of this parallelogram. We have 4 Newton force here and 3 Newton force here. Force is one side of this triangle, 3 is another side of this triangle. If we know the included angle between these two sides of this triangle, if we know this included angle, we can use cosine rule to find the magnitude of the resultant R. So what we want to do is to identify this angle as theta, get the value of theta, and use cosine rule to solve for R because we have two sides of a triangle and an included angle between the two sides. Now, what is the cosine rule? This is the cosine rule as it applies to this diagram here. 3 square plus 4 square. It means you take the sum of the square of the two sides we are talking about, 3 square plus 4 square, minus, this minus is part of the cosine rule or the formula, minus 2 times 3 times 4, minus 2 times one of the force times the second force. Minus 2 is part of the formula, then you input the two forces, 3 and 4, multiply them together. So we have 3 square plus 4 square minus 2 times 3 times 4. And finally, the cosine rule ends with cos theta. Cos theta, where this theta must be the included angle between the two sides of the triangle we are considering. Don't use cos 60 because that would be wrong. 60 is not the included side between the two sides of the triangle we are considering. We have to look for theta. Now, if you look at this parallelogram, this angle theta and this angle 60, they are adjacent angles of the parallelogram. And there is a law that says that the adjacent angles of parallelograms sum up to be 180 degrees. In other words, 60 plus whatever theta is will give us 180. So definitely theta should be 120 because 120 plus 60 gives us 180. So if we identify theta as 120, we can solve for R further from this point. So R square is equals to 3 square is 9 plus 4 square is 16 minus 3 times 4 is 12, 2 times 12 is 24, cos 120 because we just resolved that theta is 120. Let's solve further. So R square is equals to 9 plus 16 is 25 minus 24 cos 120. If you put this value into your calculator, it will give you minus 12. So 25 minus minus 12 becomes 25 plus 12. Minus times minus is plus. 25 plus 12 is 37. So r squared is equals to 37. We are not looking for r squared, we are looking for r. To obtain r, the square crosses over to form a square root. And as it is crossing over, we are taking two values, positive and negative, because r has two values. That is why it is raised to power 2. So r becomes equal to plus or minus positive value and negative value of the square root of 37. But in this case, we are not interested in the negative value because we are looking for the absolute value of the magnitude of the resultant. That's why we call it the magnitude. And that means only the positive value of root 37 is of interest to us. So R will be equals to 6.08 Newton. The negative have been discarded. We took only the positive value because the magnitude refers to the absolute value of the resultant. Now this gives us the answer to the resultant vector of this two system of forces. Now let's find the direction. What will be the direction of this vector? The direction of this vector can be identified by including an angle. Let's call it alpha, which is the angle the resultant makes with the horizontal force of 4 Newton. If we find the angle alpha, we can use it to describe the direction of r with respect to the horizontal. Now we consider this triangle again. We can now use sine rule to obtain angle alpha. And this is sine rule. Sine alpha all over 3. Sine alpha all over the side that is opposite it, 3, equal to sine theta all over the side that is facing it, r. If there was an angle here, we could also take that angle, say sine beta all over the side facing it, 4. But for sine rule, once we have an angle and a facing side and another angle and a facing side, we can solve the problem. So here we just plug in our values and find the value of alpha. So this becomes sine alpha all over 3 equals to sine 120 because theta is 120 all over 6.08 because r is 6.08 from what we've solved. We make sine alpha subject to formula. 3 will multiply this so that sine alpha is equals to 3 sine 120 all over 6.08. So this is what we have here. Sine alpha equals to 3 sine 120 all over 6.08. Sine alpha is equals to 2.6 all over 6.08. If you put 3 sine 120 in your calculator, it gives you 2.6 divided by 6.08. Sine alpha is equals to 0.4276 when you divide this in your calculator. To obtain alpha, you take the sine inverse of this value. Sine inverse of 0.4276, some people call it arcsine 0.4276. And if you put this value into your calculator, alpha becomes 25.3 degrees. So the direction of r is 25.3 degrees alpha. It makes it to the horizontal. So let's add it to it. 25.3 degrees to the horizontal. So the angle is the direction of the resultant r. So that gives us a complete solution to this resultant vector. If you understood what I have done, then try this. You have a force of 2 Newton in this direction, 1 Newton in this direction, angle of 135 degrees separating the forces. What is the resultant of the system of forces shown above? Please put your answer in the comment section, and thank you very much for watching this video. Endeavor to share this video to others so that they will come and enjoy our content, and thank you again for watching.